Institute of Engineering and Technology. And today I'm the speaker for the Power Talks, and I'm going to talk about the economic aspects of solar off-grid system. So before going into this session, I'm happy that I got this Teachers Day as today for the presentation, and I use this opportunity to thank all my teachers and also the mentor who mentored me for the session. Okay. Okay, so first I'll be giving you guys an introduction to the solar power systems, the statistics, price drop, types, and the components. Okay. Okay, so there is a prior warning. Please don't sleep or check WhatsApp during the session because that's what I do for other session. So please don't do that to me. Then coming into the statistics of PV systems in India. Here, solar system has really created a very very drastic utility grid as well. Talking about the first graph, here the bar shows the utility grid alone, where about 30 to tested, and in the second bar you can see that in the like it is combined with the solar. So when it comes to solar, about 50% like more production is done by the solar, and the utility for the utility it only costs about 7 lakh. And in the second graph, you can see that there is an increase shown in the first year. That is the initial payment user has to pay. And from the first year to the 10 or 11 or 12 years, the user will be getting back the reinvestment, the repayment. And after that, only like after getting the complete payment, only the user will be getting the benefits. Then coming to the types of the solar systems, we all know that there are types of PV systems and system. Here I've written that systems that are not connected to the utility grid are off-grid systems, and the systems that are connected to the utility grid are on-grid systems. Here the main difference is that in the off-grid system, the amount of energy we are producing like may be very less or large. Whatever we are producing, we are using it for ourselves. That is, we are being very selfish. And talking about the on-grid, it is the opposite. We'll be giving the excess energy produced to the grid. It won't be directly going to the grid, but we'll be distributing it to the end users. And according to the connection, your access to electricity, storage during excess production, and billing, etc., can vary. Here, access to electricity, considering the off-grid system, the access will be limited. Why? Because will be limited, and the storage during excess this is mainly due to the like usage of batteries. If there are no sufficient batteries for the off-grid system, then the user won't get what is desired, and the billing will also vary. Then about the price drop from 2001 to 2020, as I've written here, for 1 kilowatt PV system, the price went down from 1,76,000 to just less than 1 lakh for off-grid, and from 1,35,000 to less than 70,000 for on-grid. There's a difference in between, there's a like drastic price drop. This is because of the factors that I mentioned below: abundance of solar panels, solar panel, then the government subsidies, and then the supports. And there is also the difference that you see between the off-grid and on-grid. This is because of the components that may be like the batteries I mentioned earlier. The abundance of solar panels, nowadays we are not using solar panels just PV systems, but we are also including these panels other appliances as well. And solar plants in India. That is these are the two solar plants in India that I mentioned shown. First is a Badla solar park, and so that is that produces around 2,250 megawatts. And the second is the Sian. You know that it is the first airport, like world's first airport, to be completely powered by solar. Okay, then about the government subsidies, that is an example is Saura, which is the introduced by the KCB for us. I'll be discussing on that later. Then the NGOs. Talking about the NGO, ANERT is an example, that is the Agency for Non-Conventional Energy and Rural Technology, which in association with KSEB has come up with multiple initiatives to support renewable energy sources in Kerala. Those, these are the main reasons why the price drop has occurred. Okay. Now coming into the component solar off-grid system, the first is a solar panel charge controllers to about supply, like it provides a path to the battery tank, then the inverter to convert DC to AC, then we are using it that option generator we are put up optional because we cannot completely rely on solar panels, right? Because if the weather goes down, then വീട്ടിൽ കറണ്ട് ഉണ്ടാവില്ല. So we are using optional generators for that. Then coming into the solar on. Yes, here the difference is that we don't have batteries because we are going to give the excess energy produced that the utility grid, and this what controllers will integrated within the inverters itself. And we can see that here is a bidirectional meter which measures the current in both the directions. I'll talk about that later. So now let's discuss about these components in detail. First is the solar and solar array. So I'll brief this as written here, solar as cakes. So let's consider two places, okay? Cherai and Alamanappuram. And we are going to gather sand from both these places. And I'm going to bake two cakes out of it. The first cake will be baked with the sand using, and from only Cherai. So the cake that I and then after cutting that into equal pieces, I can get as monocrystalline. Why? Then the second cake I'm going to is by mixing both the sand, that is from Cherai as well as Alga Manappuram. The bake can be called polycrystalline because mixing of two types of crystals. Okay. Okay. So
no, break on.
okay. Am I clear now?
Yeah.
Hello.
Clear ആണ് clear ആണ്. ഇപ്പോൾ പിന്നെയും ബ്രേക്ക് വരുന്നുണ്ട്. So to the participants, we have lost some time due to the technical error. So we are limited with the WebEx meeting for around 15 minutes. So if due to some errors, if we are overtiming the clock, then I request you, all of you, to rejoin after the time limit. Okay. Let's give her a minute for the making the other activities clean. So Adi, you're there?
Am I audible now?
Yeah, you're audible.
Okay.
Yeah.
May I continue?
Yeah, sure.
Okay, so that was about the photovoltaic cells, that is monocrystalline and polycrystalline. And yes, I've written that open circuit voltage is 0.6 volt. That I'll explain with this graph. You can see that during short circuit, the desired current value is 8.8 amps, but applying the realistic condition, we won't get that value. We'll be getting only 5.5. And the similar is like considering the same thing in the voltage. The desired voltage that we want to obtain is 0.6 volt, but we won't get that value. We'll get a value less than 0.6 volt, that is about 0.3 or 0.4. Okay. Okay, so this is the solar cell, so photovoltaic cell. And arranging these photovoltaic cell, we get modules, and the modules together arranged, we get panel, which is showed here. And the next is solar array arrangement of many panels. Uh, Okay, and then about the panel rating, panels are available from 1 watt to 400 watts. But for PV systems, we opt for 200 watts and above that. And then the standard size is 4 by 9, 6 by 10, and 8 by 12. These are the available standards. Okay. And about the battery, we told that batteries are used only in operating system for the storage. Then it requires charge controllers. The function of the charge controller is to ensure that the battery is getting battery is not getting overcharged and all. And then we use the common battery that we use is lead acid battery. And in the lead acid battery, the problem is that we have to feed this battery 3 times a year. That is 3 times we'll have to fill battery water. So in order to avoid that, we can opt for sealed lead acid battery. Uh, and then other option is lithium ion. Lithium ion is a very efficient battery, but the problem is that with that is it is very expensive. Why? Because we don't have lithium deposits in India. And then the battery rating 100 to 200 then it raised from about 9,000 to 15,000. Then the best companies offering the best batteries are Excite, Loom, and Luminous. Each battery weighs from about 30 to 60 kg. Okay, so next about the charge controllers. So the prime factors considering the specification of this charge controller are the input solar panel voltage and the current capabilities. Okay. Then coming into the PWM, two types of technologies are available: PWM and MPPT. Talking about PWM, it measures the voltage of the solar panel and it steps it down in order to charge the battery efficiently. So we can say that it is stepping down the voltage. So the overall efficiency of the panel can be decreased due to this. And here buck converters are used. And for the PV systems rated less than 1 kilowatt, we are using this, and the rate is 300 to 700. Then about MPPT, it is the maximum power point tracking, and in every instance it measures the voltage and the current parameters of the panel so as to ensure that the maximum power of the panel is tracked. So we can say that it is more efficient, that is about 15 to 30% more efficient than this PWM. And also, yes, we use boost converters for this, and it is used for the panels rated above 1 kilowatt. Then about inverters, yes, inverters, we are using inverters on both off-grid and on-grid. In on-grid, it is called grid tie inverter. And then inverter usage, DC to AC conversion. Then the output configuration is 750 volt amperes to 1000 volt amperes, and it ranges from 5,000 to 24,000. Then the battery output configuration is available at 12 volt, 24 volt, and 48 volt. But for the panels rated for greater than 1 kilowatt, we opt for 24 volt and 48 volt in order to reduce the wire loss. Then the companies that provide best inverters are Sucam, Loom, VGuard, and Microtech. Okay, then about the energy meters. Energy meters, we use bidirectional meters in the on-grid systems to measure the electricity in two directions. Then additional units are measured by this meter, and the excess energy that comes up is fed into the grid. We cannot tell that it is directly fed into the grid, but it is distributed to the end users, and it prices from about 10,000 to 20,000. And before installation, we'll have to follow certain rules and regulations that has been put forth by the KCB. Okay. Yes. Next is the protection and safety device and mounting structures. The protection device we all know MCB and DLCB. MCB raised from 1 ampere to 100 ampere and it amounts from 900 to 90 to 600, and DLCB raised from 20,000 2000 and above. Then the concrete which is used for framing, that is in 3:1:1 ratio. That is the ratio of cement, sand, and stone. Then the frames are available in kgs. 20 kg of frame is used or is needed for a single panel, and yeah, it rates around 1,800. Then the other things that comes with this is mounting structures is the feeder pipes, nut and bolt, etc. Okay, so coming into the main thing, economic aspects. Here we are assuming 1 kilowatt PV systems for both, analyzing both off-grid as well as on-grid systems. Okay. Okay, so we are assuming that we are getting 5 hours of sunlight per day. So 1 kilowatt system provides produces 5 units per day. So discussing about the components, panels 250 watt into 4, so that it comes to 1,000. Both we are taking both this as same, like off grid and as well as on grid. We are taking the panels to be same, and the frame also we are taking it to be same. And then battery 12 volt 150 batteries are required. And then on grid we told that we don't need batteries. Then inverter 24 volt inverter in off grid, and in off grid it is a grid tie inverter. Then MPPT same as mentioned above in the off grid, and here in on grid MPPTs are not required. External MPPTs are not required because it will be integrated within the inverter itself. Then meter, we are not measuring this energy in for off grid, so it is not necessary there. And in on grid we are using bidirectional meters. Mm, yes, and now we are going to estimate the cost for off-grid systems first and then the on-grid systems, and let's do the comparison. Here, as we have said earlier, 5 units are produced per day. Panels cost around 46,000. Frame, we are using separate frame. That is why 4 panel frames I'm using here. It costs around 10,000. Then the miscellaneous is due to the wiring and the other components that comes in between. That is cost around 2,000. Then the MPPT 8,000, battery 12 volt 150 Ah, 2 days autonomy 24,000. Then inverter 8,000. So total is 1 lakh. So a person who is opting an off-grid system has to pay an initial cost of about 1 lakh. Okay. And coming into the same, considering the same 1 kilowatt system of on grid, yeah, panel frame and all is the same. Miscellaneous is also the same. And here the difference is the bidirectional meter and the grid tie inverter. Here both may cost around 20,000. So the total estimated cost an on-grid consumer has to pay is 76,000 during installation. And then the maintenance cost. Here, battery is the main villain. Okay. Here, battery water, we have to feed this battery with battery water 3 times a year, which costs 450. Then battery replacement, which has to be done every 4 to 6 years. And so that we'll have to pay again the 24,000 again. Okay. Then the other grease and the other maintenance items that comes with it. Now let's do the comparing off-grid and on-grid systems. Okay, so first we are doing 1 year comparison. In 1 year, initial investment is the main thing that is coming up. And here payback will be very less. Yes, and in off-grid, it will be very less when compared to on-grid. Why? Because see, I've written that in off-grid maintenance is 1,000 per year because of the battery water. And here on in the on-grid, other than battery, other things that may commonly arise, those maintenance works has to be done, right? So it costs are reduced there. Then for the cleaning, which is for both off-grid as well as on-grid. And now the 5 years comparison. Here, by this 5 years, the on-grid system is going to reach its complete payback. The user is going to get the complete repayment. Whereas in off-grid, the user will have to replace the battery. So again, this time is increasing. The payback time for an off-grid user is increasing here. Then the cleaning and the maintenance, which was what considered in the first year itself. Then we'll be doing 10-year break-even analysis. So this is 100 rupees. This is the cost per unit off-grid that we have analyzed or estimated earlier. Then cost per unit on-grid will be rupees 65. Then the KCB, what the KCB charges the consumer for 1 unit is rupees 4.5. And then, yes, the production per day. That is 5 units. As we have said that 5 units will be produced because we get 5 hours of sunlight. Then the production per month will be 5 into 30 days. That is 150 units. And the monthly savings will be 5 units into 4.5. That is what is the amount charged by the KCB. So we are saving 675 rupees per month. And multiplying it with 12, we get the yearly savings, that is 8,100. So since we got the yearly savings, it is easy for us to calculate the total years that a person may take to get the water repayment. So considering the on-grid system, we said that we have to pay an initial payment of 65,000. Then the payback can be obtained by payback years can be obtained by dividing it by the yearly savings, and it is calculated to be 8 years. So an on-grid user has to wait for 8 years to get back the total payment he has done on the system. And on the talking about the off-grid system, a person has to invest 1 lakh during installation, and not only that, the extra cost that may come up due to the battery and the maintenance works. So it sums up to 1,55,000. So see the change in years. An off-grid user has to wait for 20 years uh, to get the total payment. Okay. Yes, and next is the common possible problems that may arise. That is, other than the maintenance costs and that, the inverter malfunctioning can happen. Then the solar panels breakdown may occur within these years. Then frame degradation, and then the external factors are, you all know what those emojis mean. They can what cause wire damage to wire and all. Then the other things that may come are short circuits due to water logging, etc. So these are the chances. Okay. And yes, the verdicts that a person or a user has to face is the advancements in solar panels. The technology is developing day by day, so the more efficient cells and all may come up in the future. And more plants in India, as I mentioned earlier, Badla solar park are what major solar are in available in India. So it is also increasing, and thus the price is expected to decrease in the future. And then the government subsidies like Saura, which I mentioned earlier, which is provided by the KCB. Then all these are here to support the off-grid as well as on-grid users. So, and the other thing is the global capacity. Yes, the global capacity, we are estimating it to increase up to 18 times.
Hello. Adi, you're not audible right now.
So talking about this Saura, it is introduced by the KCB for its users, and they are aiming to set up 38 gigawatts rooftop panels. And this is the phase 2 of what they have released earlier. They have released phase 1. This is the phase 2, and this 3 special subsidy modules are also implemented. And Since Kerala is allotted with 50 megawatts under the scheme, around 75,000 applications. So that's all, and so that's all about the session. Now I think you guys have got a clear idea on what is feasible, whether like implementing the solar at your home is feasible, or comparing this off-grid and on-grid, what or which will be feasible in the future as well. So next is a Q&A session. If you guys are having any doubts. Hello. I'm sorry for the network issue, so that I had to end this fast. Anybody having any doubts?
I think Vignesh has to say something. He told that whether you could explain the cake or the solar panel making process once again.
Okay, I'll explain. Yes, so the concept is that we are considering solar panels as cakes. I'm audible, right?
Yeah, audible.
Okay, thank you. So we are considering the solar panels as cakes. Here, I am going to take sand. I'm going to gather sand from two places. That is Cherai as well as Alva Manappuram. And I'm going to bake two cakes out of it. The first cake will be of the using the single. I'm sorry, taking the sand from the single place, that is Cherai. So after baking the cake, I'll be cutting it into equal pieces, and what I get out of it, I can name it monocrystalline. Why? Because I have taken sand from a single place. And the second cake I am going to bake is by mixing these two sands, that is the sand from Cherai as well as Alva Manappuram. So, baking the cake and cutting it into equal pieces, we get cells, and these cells can be named as polycrystalline. Why? Because I have combined the sand from both the places. Here, the difference is that in monocrystalline, the sand is considered as a single crystal or single type of crystal of silicon, whereas in polycrystalline, this sand of both the places are taken, right? So it is like what two types of crystals are used, and which will be more efficient. Monocrystalline will be more. Okay, I think you got the concept.
Yes, ma'am.
Vignesh, any other doubts? Okay, so Amy Alex is telling no doubts. Anyone else? Vignesh, any other doubts?
Oh, I got no doubts. Like, all clear.
Oh, oh, thank you. Okay, so Naveen has also got no doubts.
I think that's it. Madhu can take over, right?
Okay. Okay, so thank you for waiting as well as attending this session. Okay, and thank you for the ones who supported me in completing it here. Thank you all.
So I think Madhu also has got some technical issues with his network.
Mm.
Yeah. So, okay, so we'll conclude, I think. Madhu, if yes, can you just reply in the chat box? And exactly where
Oh,
is your
okay.
house
He is.
exactly at Kollam?
Mm, he is telling that he is not. Yes, he is speaking, but we are not hearing.
Yeah.
Okay, he is telling
I
we
shall
are not.
conclude it.
Yes, okay.
Thank you, Aditya, for presentation on economic aspects of solar off-grid systems. I hope it was informative to everyone. I also thank all the attendees for registering and joining us for this evening. So thank you all, and thank you, Aditya.
Thank you. Thank you.
Okay.